Welcome to this presentation on simulation and optimization using the ternary search algorithm. My name is Sumanth and I am an undergraduate student from Section B in the Department of Electronics and Communication with roll number 620232 at NIT Andhra Pradesh. In this presentation, we will explore the concept of optimizing a function using the ternary search optimization algorithm. We'll begin by discussing the fundamentals of optimization and the importance of choosing the right algorithm for the job. Then we'll introduce the ternary search algorithm and explain how it works with the help of examples. Whether you are a student, researcher, professional, this presentation is designed to equip you with a better understanding of simulation and optimization using the ternary search algorithm. So let's get started. In this presentation, we'll start with an introduction to optimization and the importance of choosing the right algorithm. Next, we'll look into the flowchart of ternary search algorithm and the mathematical expressions used in the optimization process. We'll then move on to one numerical example where we will apply the ternary search algorithm to a function and evaluate its um, performance. Afterward, we will provide a Python code for ternary search algorithm which will help you understand how to use the algorithm for your optimization tasks. We will also discuss the demerits of the algorithm and how to overcome them. Finally, we will present an application of the algorithm in a real world scenario which will help you understand how to apply the algorithm to your own projects. Optimization is the process of finding the best solution from all possible solutions to a given problem, given a set of constraints. It is used in wide range of applications such as engineering, finance, transportation, medicine, and many more. The main goal of optimization is to improve efficiency, reduce costs, improve productivity, and enhance performance among others. In optimization, a function is a mathematical relation of the relationship between the input and output variables. A unimodal function is a type of function that has a single global minimum or maximum point. This means that the function has only peak value uh, in the given graph. So, an example of a unimodal function has been provided here. Take a look. Let's dive into the algorithm of ternary search optimization. The provided algorithm here is for minimization problem, and in the first step of this algorithm we have to initialize two variables a and b such that a is the left boundary and b is the right boundary of the search interval, and in the next step we have to calculate the range of search interval, that is b minus a, and compare it to the tolerance parameter. Here tolerance parameter is used to determine the termination step. The value of tolerance, that is epsilon, will be in the range of 10 power minus 7 to 10 power minus 9. If b minus a is less than epsilon, then the algorithm returns the value of a plus b by 2, and then we'll get the minimum of the given unimodal function. If the size of search interval is greater than epsilon, then we'll consider two internal points that are c and d in such a way that c equal to 2a plus b by 3 and d equal to a plus 2b by 3. The reason why we are taking two internal points is to divide the search interval into three parts. The three parts will be from A to C, C to D, and D to B. Then we will compare the values at f of C and f of D. And if f of D is greater than f of c, uh, the rightmost interval will be replaced by the value of d, and if f of c is less than f of d, the left bound is replaced with the value of c, and this process will takes place until p minus a is less than epsilon, and at some point of time b minus a will be greater than epsilon, and there we will get our minimization. So this is the algorithm for minimization type of problem. In the coming slide we are going to implement this algorithm in Python. Before diving into the simulation of algorithm, let's have a glance at mathematical expressions that have been there in this mentioned ternary search optimization algorithm. So here A is the left boundary and B is the right boundary for search interval. A plus B by 2 returns the value at which the function will be minimum or maximum. In this case, since we are implementing uh, the algorithm to a minimization type, it returns the value at which the function will be minimum. Here C and D are the two intervals at which the search interval is divided into three parts. So let's see a diagram which will explain more about the division of the interval. Let let us assume that uh, a comma b is the search interval, and then C and D will be the division of points. Uh, the search interval is divided into three parts such that A comma C is the first part, C comma D is the second part, and D comma B is the third part. And if f of C is less than f of D, then the third section will be neglected or ignored, to be precise. If f of D equal to f of C, then um, the function will return a plus b by 2 as the value of x, that is the point at which the function will be minimum. So the Python code for ternary search optimization algorithm is mentioned here. So the first step we have to do is to import two libraries that are matplotlib.py plot. So the first library is used to plot different graphs of different functions, and numpy is used to work with different mathematical expressions. And then we have to define a function called ternary search and implement all steps that are there in ternary search optimization algorithm. Here EPS is the tolerance parameter, and the value of tolerance parameter here is 10 power minus 7. So the function of ternary search is highlighted here. Here f takes the unimodal function as input, and a is the input which is lower boundary of the interval, and b is the upper boundary of the interval. This particularly this part of the code is used for visualization of the given input unimodal function and the value at which it is minimum. So this is what the program is, and we'll move on to the next slide. A numerical example is provided here. Here we have considered a function f of x equal to x cube by 3 minus x square by 2 minus x minus 1. And the graph of this function is mentioned in the next slide. Here a equal to 1 and b equal to 2. In the first iteration, c will be 1.3 bar and d will be 1.6 bar. Then the algorithm calculates the value of function sets c comma d and compares both of them, and it will decide whether it has to proceed to the next iteration or not. In this example, it took 34 iterations for the algorithm to find the minimum of the function. One thing that I want to mention here is the given function is unimodal function because the given interval is from 1 to 2. If the interval is changed to -2 to 3, then this function will not be a unimodal function. Since the interval of the function is from 1 to 2, 1 is y equal to sorry x equal to 1 is represented with green line and x equal to 2 is represented with violet line. So in this interval the given function is a unimodal function, and um, the minimum of the function can be found at x equal to 1.618, and the value of the function at the point 1.618 is minus 2.515. So now we'll move to the next slide. So the algorithm worked fine for the other four functions that are mentioned here. Now let us consider the whole function. But now we will change the interval of the function to -2 to 3 from 1 to 2. Then this function will not be a unimodal function since it has a minimum and maximum. So the simulation result is provided here in the right side. As we can see, the algorithm converged uh, at local minima, but the minimum value in the given interval is found at x equal to -2. So this function in the given range will specify that our optimization algorithm will not work for multimodal functions. So few demerits of the ternary search optimization algorithm are mentioned here. So for the first thing is slow convergence compared to other optimization methods as gradient descent or Newton's method. And since the computations are more, the computation cost is also more. And the main problem or the main demerit of this optimization algorithm is it is limited to unimodal functions. That means it will not work to the functions which are unimodal in nature. Before diving into the application of this ternary search optimization algorithm, the advantage of ternary search optimization algorithm is it is simple to implement, and its efficiency makes it a valuable tool to have in your problem solving toolkit. So since I am from electronics and communication, I took an application which is related to our branch. So the application is optimizing amplifier design with ternary search algorithm. In amplifier design, it is crucial in electronics and communication. It involves high gain, maintaining noise figure, and stability. So the ternary search algorithm has shown great results in amplifier design optimization. So in the following slide, we'll explore how the ternary search optimization algorithm can be applied to the amplifier design and the benefit it offers over the other optimization algorithms. We'll move on to the next slide. So the algorithm works by dividing the search space into three equal parts, as we all know, and evaluating the function at each of these points, and it will determine which part of the space contains the optimal solution. The ternary search algorithm is particularly useful when the function is being optimized is unimodal, which means it has a single maximum or a minimum value. So in the amplifier design, the ternary search optimization algorithm can be used to find the optimal values of different transistor parameters such as gate width, length, gate oxide thickness, drain bias voltage, and others. An important point that we have to look into is, compared to other optimization algorithms such as gradient and genetic algorithm, the ternary search optimization algorithm can find the optimal solution with fewer function evaluations, which can significantly reduce computational costs and time required for the optimization process. So it is better to choose ternary search optimization algorithm uh, instead of gradient based and genetic algorithms in order to save time and computational cost. And that's the end of our presentation. And that concludes our presentation on the ternary search optimization algorithm. We hope you found it informative and valuable in understanding how to optimize functions and solve complex problems efficiently. Remember that the ternary search optimization algorithm is just one of many powerful optimization algorithms out there, but its simplicity and efficiency makes it a valuable tool to have in our problem solving kit. If you have any questions or comments, feel free to leave them in the comment section below. We appreciate your feedback and suggestions for future topics. Thanks for watching, and we hope to see you in our next video. Goodbye.